right, happy Friday morning. I have to say, if they're eating corn dogs, y'all are in school. All right, so hopefully you've done your warm-up. Let's go through. This is a review of yesterday's basic two-step equations. Again, it's early, should be a review of what you did last year, but let's go through the process anyway. My habit is always to identify the variable term and to find the equal sign, because those are two very important parts of the process. That's because the last thing I'm going to do is deal with the variable. I'm going to use inverse operations to move my constant, so I'm going to add 8 to both sides. That leaves me with 1/3 m equals -5. The opposite of multiplying by 1/3 is dividing by 1/3, dividing by 1/3. And that cancels, and you end up with m equals something. Now, some of you had trouble dealing with fractions when you were in 6th and 7th grade. If that's the case, then you can also type into your calculator -5 divided by, parentheses, 1 divided by 3, hit enter, and it will tell you that the answer is -15. Now you ask yourself, is that the right answer? What should you do before you box it? You should plug it back into your original equation for the variable. So we end up with -8 plus 1/3 times -15. When we solve that, when we distribute, we end up with -8 plus -5, and that does indeed equal -13. So we can box our answer on the other side. Done, done, plus 8, plus 8. We have m divided by 3 equals -5. Inverse of dividing by 3 is multiplying by 3. So we end up with m equals -15 on this side as well. Why is that? That's because hopefully you figured out by now in your math journey that multiplying by a number is the same as dividing by its reciprocal or its multiplicative inverse. Meaning, multiplying by 2/3 is the same as dividing by 3/2. Multiplying by -4 is the same as dividing by -1/4. Those are the exact same mathematical function. So let's get into what we're going to do today. Today we're going to deal with variables on both sides. It doesn't really change the process, it just adds a step or two based off what it looks like. Your goal is to first move all your variables to one side, and then move your numbers to the other. Then solve just like normal. Combine like terms, solve for the variable using inverse operations, and please, please, please make sure you check your answers. Let's roll. So we have a variable guy here, and we have a variable guy here, and there's our equal sign. Now again, our goal is to move our variable guys to one side and get our whole numbers on the other. So that is exactly what we are going to do. So we're going to add 2i. The only way you can move something from one side to the other is through addition or subtraction. That gives us 8y minus 13 equals 11. Add 13 to both sides. 8y equals 24. Divide to solve, and y equals 3. Now I'm not doing anything until I have checked it. You have calculators, there is no excuse to skip this function. I'm telling you that because I know some of you are going to, and eventually at the most inopportune time, it is going to bite you in your behind. I'm going to count it wrong, and then I'm going to put ha on your paper because you did not check. So let's do 6 times 3 is 18. 18 minus 13 is 5. On this side, we have -6 plus 11, which is 5. 5 equals 5 is indeed a true statement. Therefore, y equals 3. On the other side, line. Now, on this side, we have parentheses. We need to get rid of those parentheses through distribution, so let's do that first. -6x minus 10 equals -12x plus 2. Now we begin to move things. Plus 12x, plus 12x. This gets me 6x. I'm going to go ahead and move the 10 to the other side. That gets me 12. Equal sign stays where it is. Divide both sides by 6, and x equals 2. I'm not boxing anything until I go back up to the top, and I plug in 2, parentheses, -3 times 2 minus 5. That you can type into your calculator and then see if it's the same as -12 times 2 plus 2. what you should find when you punch it all into the calculator is that both sides equal negative 22. So our check is complete and we're good to go. Next, on the next example, line. Now I can see based off of this, here's a variable guy and here's a variable guy, that if I move things to the left, I'm going to end up with a negative coefficient. I, personally, do not like negatives, so I'm actually going to subtract 2.5a from both sides, which moves my decimals or my variables to the right. And I end up with 1.2a minus 8 on the right-hand side and just 4 on the left. Now I'm going to add 8. That gets my constants to one side and my variable terms to the other. Divide both sides by 1.2. And I have an a value of 10. A value of 10. Again, I'm going to plug that in. I have 2.4 times 10 plus 4 equals 3.6 times 10 minus 8. This is 36 minus 8, which is 28. This is 24 plus 4, which is 28. My check is good again. That makes that definitely my answer. It's the value of a that makes it all true. And finally, here we have fractions. Now, you can go ahead and do fractions if you want. I don't like fractions. I'll show you what it looks like with fractions and without. Let's draw a line. We end up with adding 1/5 a, adding 1/5 a. Now, adding 1/5 a is 1/2 plus 1/5. I have to have common denominators. Go through that entire process. So it's 5, 6, 7 tenths a minus 4 equals 6. I add 4 to both sides. And 7 tenths a equals 10. Inverse operation suggests I just need to divide by 7 tenths. Divide by 7 tenths. That's 10 divided by 7 tenths, which is 10 over 1 times 10 over 7, which means the a equals 100/7, or simplified 14 and 2/7. Now I can check this, but I will tell you something about the calculator. The calculator does not like mixed numbers. So when you plug in a, you have to plug in that mixed number in for a. Make sure you use all your proper parentheses and see if it's true. Now, I want to show you the way that I would have solved this. If I had that same problem of 1/2 a minus 4 equals 6 minus 1/5 a, because I don't like fractions, I never have, and I've certainly never been very good at them, I know that if I multiply the entire equation by a number, I can get rid of fractions. Give you a quick example. We all know that 2 plus 3 equals 5. If you multiply this entire equation by 3 and distribute it to every number, you end up with 6 plus 9 equals 15, which, by the way, is also a true statement. So the moral to our story is if you multiply the entire equation by a particular number, it stays true. So if I multiply this entire equation by 10 and distribute the 10 to every number, watch what happens. 10 times 1/2 is 5, so I end up with 5a minus 40 equals 10 times 6 is 60 minus 2a. Now, you may not be able to do the computation as fast as I did, but it doesn't change the fact that you have a calculator that can help you through the process. But the greatest thing about this whole thing is no more fractions. No more fractions, and I can now solve. I'm going to add 2a to both sides. That gives me 7a minus 40 equals 60. I'm going to add 40 to both sides. I end up with 7a equals 100. I divide both sides by 7. And look, I have the same answer I had before. Any questions? Fantastic. All right, so next screen, let's take a look at some special cases. Special cases are things that are where we don't end up solving for the variable. Let's just watch. So again, we have parentheses, so we're going to get rid of those parentheses. So we end up with 14x plus 14. Make sure you distribute carefully. Now, when you end up with like terms on one side, you want to combine those like terms first. So you end up with 14x minus 7 equals 14x minus 7. Now, you'll notice that looks a little bit unusual, but let's go ahead and move our variables. I always move variables first. So you subtract 14x from both sides, and what happens to the x term on both sides? They both go away, leaving you with negative 7 equals negative 7. Now, in instances where the variable goes away and you're left with a sentence that is true, which this is because negative 7 equals negative 7, then the answer is all real numbers. Because any number, all real numbers, or our fancy little symbol, because any number you plug in for x will end up being a true statement. And you can check. I always usually check a positive and a negative number that are different. That will sometimes help me figure it out. So when you end up with a sentence with no variables that is true, then your answer is all real numbers. Let's go to the other side. We distribute again. We end up with 3x minus 15 equals 3x plus 15. Again, we draw our line. We move our variable term first. Now again, the variable terms end up going away, leaving us with this sentence. Negative 15 equals positive 15. That is not a true statement. Guys, negative 15 does not equal positive 15. When it is a false statement, the answer is that there are no solutions for x. There is not a single value for x that will make that sentence true. So again, variables go away, true statement, all real numbers. Variables go away, false statement, no solutions. Now, you have classwork keys, and you have homework. Work quietly, work smartly. Have a fantastic weekend. I'm going back to my corn dog. Bye.